Qualitative analysis question from June 15, variant 3.1. Again, in this way, we are analyzing our salt for the cations and anions, and in the same way, like previous videos, we have to see any color change, formation of precipitate, or solubility of such precipitates, and if there is any gas evolved, we have to test that gas and we have to write that in the appropriate box. Today, in this question, they have said, in the previous question of this paper, of course, it's question number 3. So the previous question of question number 1 and 2, they might have given you something related to Fa2. So the same thing we are going to continue in this experiment, that Fa2. This is a solution prepared from hydrated ammonium iron 2 sulfate, and this is hydrated, and this is iron 2 sulfate, and this is ammonium. So in this case, Fa2 contains 2 of the cations given here, ammonium, Fe2 plus, and anion is sulfate. They have said to a 1 centimeter depth of Fa2 in a test tube, add a small spatula measure of sodium carbonate and record your observation. So in this Fa2 given, we have to add sodium carbonate and then we have to record the observation in this box. Now we will take 1 centimeter depth of this Fa2 solution, and in this solution we will add a small spatula of sodium carbonate. So we will see what is happening in this tube. So this is a small spatula of Fa2 is added with a small spatula of sodium carbonate. So with the wall, and what is happening? The fizzing is happening. The bubbles are coming up. If we add a bit more of this sodium carbonate, so we'll see huge fizzing came up, and the solution has turned into green precipitates. Now we'll record this observation here in this space. So here we have recorded that 1 centimeter depth of Fa2 is when added with sodium carbonate powder, effervescence or fizzing appeared, and that solution turned into dark green precipitates. Now they are saying solution containing Fe2 plus ions can quickly be oxidized in air if they are prepared by dissolving the solid in distilled water. Use your observations to suggest what other substance was added to solid this to prepare Fa2. It means whenever you add sodium carbonate in any of the substance and you got fizzing, it means the substance contains some acid content, because sodium carbonate, being a metal carbonate, can give fizzing with any acid. So the conclusion here is, when they have prepared this, they must have added some acid here, and if we look at the anion sulfate, it means the acid must be sulfuric acid H2SO4. So we have recorded here that it contains sulfuric acid, which was used in the preparation. Now moving on to the next part of this question, they have said Fa6 is a mixture of 2 salts. Now here is Fa6, and the appearance of Fa6 is green solid. It's green solid. Now they have said it's a mixture of 2 salts. Each contains a single cation and a single anion from those listed in qualitative analysis notes. Do the following test and record your observations in the table below. Now we have to look for the cations and anions. We are starting off with the first test in this page. Place a small spatula measure of Fa6 in a hard glass test tube and heat strongly. Now, here this is what we call boiling tube. It's actually made up of a hard glass and it's basically a bit thicker than the rest of the normal tubes. This is made up of Pyrex. We can see it's here, Pyrex written. So this Pyrex means it's made up of a hard glass which can bear higher degrees of temperature. So today we are using this test tube for heating, and the same test tube we use for boiling purpose also. Now we have another tube which is also made up of this Pyrex. Here you can see this Pyrex tube. So we can also use this test tube. It's a higher grade test tube. We can use this for boiling as well. So in order to save time, we will use the thin tube. Okay. So we have taken here our Fa6, which is a green solid, and we will heat this strongly by putting this test tube holder. Spread this a bit so that heating will be done for all the solid equally. Now we will heat this test tube in a way that it will be tilted a bit. We must not heat it this way because if there is any gas or vapors liberating, so they must be condensed on the neck, so we can see there is any vapors liberating. Therefore we will be using this way. So now let's heat this tube. Strong heating means we will put this on the flame and the flame will cover from all the corners of the tube. This is what we call strong heating. And now in this heating, first observation I am getting here is the water vapors are condensing on the neck of the tube. Here are the water vapors, we can see clearly. And now we will see what is happening to the solid. Solid is showing a bit of spitting, and also it is changing its color from green. It is turning into gray and then black from the corners also. So let's completely heat this green solid and we'll see if there is any permanent color change for all the solid happening or not. And now we can see the total solid content from green has turned into gray or black solid. And neck contains the condensation of water vapors. Yeah, that's done. So we can see it's totally a black solid now. That black solid and condensation on the neck of the tube. We will record this observation in the column now. Next test says in a small spatula measure of Fa6 add sulfuric acid followed by sodium hydroxide. Now we will take a small spatula of Fa6 in this test tube, but before we take a small spatula, let me tell you about the small and full spatula. So if we take this way, it's a full spatula, and if we drop most of the content and we take just like this is a small spatula, even lesser than this. So this is what we call a small spatula. So we will take this small spatula measure in this test tube and we will add sulfuric acid first until the reaction is complete. So here is the sulfuric acid and this is the dropping pipette we will use, and we will observe the changes happening in the content of this test tube. So as soon as we add sulfuric acid, we can see fizzing started. Add more sulfuric acid and the solution is showing a lot of fizzing until the reaction is complete. We have to add sulfuric acid. So this is sulfuric acid added. Still we are getting a bit of fizzing, so let the reaction complete. And we can see the solution is gradually turning into light blue color. So until the reaction is complete, fizzing is still happening. In order to dissolve the bottom part, just tap a bit from the bottom, rotating the tube. Now we can see that the content of the tube are gradually turning into a blue solution, which is a very light shade of blue because it was green in the first place when we have added the powder. So this reaction is completed here. Now we will continue adding sodium hydroxide here. So using this tropic pipette again, we are adding sodium hydroxide, and of course when we add sodium hydroxide, we keep in our mind that it is used to test cation. Therefore, we add sodium hydroxide in two steps. Number one, few drops and then excess. So let us add in few drops first. So once we add sodium hydroxide in few drops, we can see the blue precipitates are forming. And if we add sodium hydroxide in excess, those blue precipitates remain insoluble. Now we have recorded this observation here that fizzing happened followed by light blue solution formed. Then upon adding sodium hydroxide in the same test tube, we got blue precipitates with a few drops of sodium hydroxide, and the precipitates remain insoluble in excess. Proceeding on the next test, we have to a 3 centimeter depth of a distilled water in a boiling tube, add the remaining sample of Fa6, stir and then filter the mixture into clean boiling tube. You will use this solution for the tests 4 to 6, and they have crossed out this box, means you do not have to observe any change happening or not. Just we are using this solution in 4, 5 and 6 parts after getting the filtrate. So let's perform this. Now in the boiling tube we have taken the remaining sample of Fa6, and now we will add 3 centimeter depth approximately up till here the distilled water from this bottle, and we will stir to dissolve. So we have added approximately 3 centimeter depth of water, and now we are stirring to dissolve. Once it's completely dissolved, we will filter this. Now how to use the filter paper? Let me tell you about the filter paper also. First of all, we will take this filter paper and we will make it in a type of funnel. So we will fold it equally first, another fold equally like this, and upon getting this type of thing, we will open it from one of the part. So it's type a cone now. So we will put this cone here in our funnel like this. Now we will use this funnel in the clean boiling tube to get filtrate. The solution which we have prepared in the previous part is actually then added to filter. Now, as soon as we will add from the top, you can see filtrate is collecting, which we have to use in the remaining 3 parts. So this is the filtrate we got, and removing this funnel, we will use this filtrate for rest of the 4 tests. Now in the next part they have said to a 1 centimeter depth of this solution from part 3, in a test tube add aqueous sodium hydroxide, and the next test is in the same 1 centimeter depth of the solution taken in from 3 test tube, add aqueous ammonia. Now let me remind you that in these two parts, sodium hydroxide and ammonia are added, and we add these two solutions to detect cation. Therefore, we will perform this in two steps: first few drops and then excess. And also with sodium hydroxide, we warm the mixture with moist red litmus paper for the ammonium ion detection. So let's continue with this test. Now we will take 1 centimeter depth of this solution, and we will take sodium hydroxide to test this. First of all, we will add in a few drops followed by excess. So here we can see, if we add few drops first, solution is turning into white precipitates. If we add extra, means excess, we can see those precipitates are not dissolving. It means white precipitates which are insoluble in excess. Now we will take 1 centimeter depth of the solution again to test with ammonia. So this is 1 centimeter depth of solution, and we will add aqueous ammonia using a dropping pipette again. And now we will see if there is any precipitates forming with few drops. So as soon as we have added few drops, white precipitates start forming. And if I add this in excess, those white precipitates are not dissolving. So white precipitates which are insoluble in excess. We will record this observation. So we will record this observation here: white precipitate insoluble in excess, white precipitate insoluble in excess. So from here we have concluded that blue precipitate insoluble in excess when sodium hydroxide is added. So this is blue precipitates insoluble in excess with sodium hydroxide, means one of the cation is copper 2+. And the next observation was, in sodium hydroxide and aqueous ammonia, we got white precipitates insoluble in excess in both. So from here we can conclude that it's magnesium, because white precipitate insoluble in excess in both of the aqueous ammonia addition and sodium hydroxide addition. It means magnesium 2+ is the second cation. So the two cations which they have said, two salts each contain one cation, means two cations are copper 2+ and magnesium 2+. Now we will proceed with the next test to the 1 centimeter depth of the solution from part 3 which we have made here. We will again take 1 centimeter depth of that, and then we will add aqueous barium chloride or barium nitrate. Now this barium chloride or barium nitrate is added in order to identify the anion, which is here sulfate or sulfite ions normally are detected by adding any salt of barium, that could be a chloride salt or nitrate salt. So we get white precipitates upon addition of barium salt. This is for sulfate or sulfite. It means in the last part they have asked you to detect sulfate or sulfite. Let's perform this test now. Now we will take another test tube with 1 centimeter depth of this solution made in part 3, and we will add aqueous barium salt which we have today, barium chloride. So let's add this barium chloride. Upon addition of barium chloride, white precipitates are forming. It means sulfate or sulfite could be present. So we will record this observation here that white precipitates formed. So we have recorded here white precipitates formed, which means this salt contains either sulfate or sulfite. So this is one of the anions, sulfate or sulfite. What is the other anion? Because in the question they have said two salts and there are two cations, each cation and each anion means two salts contains one cat, one anion. So two anions must be there. So this is one of the anion detected, white precipitates with barium salt means sulfate or sulfite. Now, again, if we look at this test, they have said Fa6 when added with sulfuric acid and fizzing happened. It means this salt must contain some carbonate because carbonates react with any acid to give you fizzing, that means carbon dioxide. Therefore, two anions detected must be carbonate and sulfate or sulfite. So we will record this here that two cations we have detected are copper 2 plus and Mg2 plus, and anions are carbonate and sulfate or sulfite. So we have recorded all these cations and anions detected. Now, in the next part, they have said, describe a further test that would allow you to determine exactly which anions are present and explain your choice. Do not do this test. Means we do not have to perform this test, but we have to confirm whether the salt contains sulfate or sulfite, because carbonate is confirmed, of course, but sulfate and sulfite has confusion. So now let's look in the table. What we have done is we have added barium salt, and in these two sulfate or sulfite ions, barium 2 plus salt will give you white precipitates. So we are confused with this, but let's read the further test. Insoluble in excess of a strong acid, soluble in excess of a strong acid. It means if the precipitates formed, we add a strong acid, the precipitates will either dissolve, means soluble, confirming sulfite, or if they are insoluble on addition of this strong acid, it confirms sulfate. We do not have to perform this test, therefore we're not performing, but we will just write this test here that add further sulfuric hydrochloric acid. We cannot add sulfuric acid because it contains sulfate. So please do not add sulfuric acid here. Only acid we can use here could be hydrochloric acid or nitric acid, because if we add sulfuric acid, it contains sulfate ions already. So we have added this test here, which must not be performed. And here we comes to an end of this 13 marks qualitative analysis.